My name is Claude. Actually, it's written there, Claude Remillard. You do with it what you can. Basically, I'm a group program manager at Microsoft. And I'm responsible for a couple of products, including DevOps related tools from an Azure perspective. And with me today, I have Andy.
Hi, my name is Andy Glover. I work for Netflix, and I run delivery engineering for Netflix. We recently, a year ago, open sourced a project called Spinnaker, and I'm going to tell you a little about it in a little while.
All right. So I'll just go over a couple of slides, maybe just, talk about myself because it's an important subject to me. So I've been doing DevOps and automated pipelines for quite a bit. Actually, I'm at Microsoft. Before that, I was in a consulting company doing dev practices and ALM practices, so application lifecycle management. And somewhere along the way, we actually encountered a lot of issues between dev and ops, and we started doing a bunch of systems. We then productized it under a product called in release that Microsoft acquired about 3 years ago or so. So then and that product became Visual Studio Release Management. So I managed that for a while, and about a year and a half ago, I started actually another product, which is called Azure DevTest Labs, which allows you to spin up labs in the cloud to do dev and test environment quickly. So today I won't talk a lot about labs. I won't demo labs. What I'm going to talk about is how we work and how we do the work on labs, and basically how we're deploying our service on top of Azure. So we're one of the 70, 80 services on Azure. So I'll go about that pipeline approach. The other thing I'm also managing is other DevOps tools, and we're basically from an Azure perspective. So that's where also we're working with Netflix on Spinnaker and a few other initiatives. But really the goal is I'll go over kind of our pipeline and then take a bunch of questions at the end. So really when we think about how we do pipelines or DevOps is, the way I think about it is what you're trying to do is a bunch of stages where actually you want to go to prod with something that won't break everything, and that allows you to push your new features faster. You've heard that over and over. So the way we always thought about it is that, you want to do your expensive test later, so that basically you start with cheap on a candidate of what your code is, and as you go forward, then you do the more and more expensive tests. A guy looking at a screen is an expensive test. Running a unit test is a cheap test. So often you kind of build your pipeline with the mindset of saying, I'm going to do different types of tests from one part to the other. And obviously, the more you automate them, the cheaper they are, the best it is for you. So, and the big change, I think what we've seen over the last few years with the idea of DevOps is really this idea to go with faster change with smaller things. Actually, if you look at it, at least my perspective, over the last 10, 12 years doing that, when we were first started doing kind of taking care of deployments in organization, it was really kind of somebody in IT getting a bunch of actually documents that needed to be updated, that needed to go and run all of these things and all of these steps, and it was hard and it broke often. So we didn't do it often because we were kind of scared about it. So that kind of was the first step. And again, that was stressful, those weekends and whatnot. Hopefully you're not doing that anymore, but if you can't go away from that first step of manual deployment, that's costly, that's difficult, that's stressful, and it delays your value to your users. All right. Then we went to a scripted approach where basically you kind of semi-automated it. We wrote a bunch of scripts, and then you had a series of scripts to run. You were not fully automated, and you had a script for each of your environments, and now at least you didn't go and run all your commands, but you had, you semi-automated with a bunch of scripts and so on and so forth. So that was a little faster, a little more sturdy, but again, still kind of a slower process. And we got into the brittleness of all these scripts. That's where I started building the in-release product, which I think what we saw is often the scripts were out of sync, and there was a lot of not very predictable what would happen when you have them, and we were building all these things to make sure that we didn't break things in terms of big test environments and big delay in tests, instead of kind of going to next step, which is to say, no, at every one of these stages, you basically have everything and you can go and automate. I'm going to go to dev and integration, staging, and prod, and I'm going to fully automate there with kind of an abstraction on top of it, where I can say, well, when I'm in dev, this is my scripts. They're in source control somewhere. It's the same script, and what I'm varying from one environment to the other is the values I'm going to pass on to these scripts. So we're getting in, into secrets management. We're getting into managing these different values, and that's what basically kind of the new config as code tools that we've been seeing over the last 3, 4, 5 years being adopted. And you can go quite fast, and actually in every one of your stage, you can go and deploy your app and basically perform whatever you want to do, even if it's, some weird poster. And then the next step we saw over the last few years, and that's what for us was interesting, is kind of change the idea. So every time you get to a new stage, you need to put roughly, like I often see it as a cake, where you have a base layer, your OS, and then you put some common tools, database and whatnot, and then you put your own bits on it. So you build your cake at every one of these automated deployment. Again, a lot of different things that can vary. So the next evolution to that is to say, well, I'm going to build it first with an immutable approach. So, and then my actual act of deployment is just to create a new instance of my VM or my container based on a common set of images I have. So the deployment itself is no longer where the complexity is. The complexity is at the bakery or baking those images. And that's what we're seeing, like, again, a lot of container going. In many ways, I kind of see a lot of people kind of trying to go directly to container as a way to, a bit like we did with cell phones, going to the, skipping the landlines infrastructure and going directly to cell phones. So there, it's a pattern that we see more and more, like to start to think about more an immutable approach. And again, you still have the same problems. You're going to go to these stage, but the actual act of deployment is different. And also, when you get in prod, what you're managing now is, now I have different versions of these different containers or VMs, and I'm starting to manage now traffics to them and how I deal with them as opposed to just being focused really just on the deployment. That being said, so we kind of do from an Azure perspective and Azure tools, we do a lot of these. Patterns, we do support Kubernetes, and we have an Azure Container Services and all this. But what I will focus today, and we thought would be interesting, is I'll go over our pipeline, which is more config as code type of pipeline. And then Andy's going to go and show how they're doing with more of an immutable based on images, and then we'll take questions. All right, so if you can switch to, thank you. So we're using VSTS. So that's kind of, VSTS, for those who don't know, it's a platform where you have a bunch of things that you need for your whole life cycle. So this is our own live project. So I'll show you things. I won't actually execute many things because it's actually a live system. So if you look in there, so when we get in there, we got a lot of things. I just wanted maybe to show your attention here on that bug curve, which I was happy to see the last few days. I'll come about that. So one of the first things we have is really kind of doing the work management. One of the key things from a pipeline is, of course, if I have this big piece of software, all these components, changing them all at the time, my risk is very high. So one of the key things is to start with small things and fly them quickly. So we are a Kanban team. We use Kanban as an approach, and we try to have small things. So I'd say the first takeaway from really deploying regularly is to work between we call them PM or product owners and devs, in a way to really define small pieces, the smallest size of value that you can have, so that you work on smaller things. We found also that by working on smaller things, the smallest we can go are often in the same order of magnitude. So everything about planning and forecasting and so on and so forth, actually we just count the numbers we have, and it's close enough. We don't even do sizing anymore. Basically everything is a story, and we count number of stories. We push roughly over time, and we focus on pushing more and faster. The other thing that you'll see here, which is a kind of a DevOps thing, is blue is feature, red is bugs. Oh, that's interesting. So again, it's a live system. Sindhu just moved it. So all right. so we're starting from on deck, which is the next thing. So that's us, the POs. We put what's to work next. And our strategy is that we fix bugs first. So when a bug is known and we find a bug, we make an instant decision, which is it goes into two categories. We fix it now or we'll never fix it. There's no other thing. So all we do is bugs are a priority. So if you look at my board right now, I have, we said on the other one, I have 15, 16 bugs. And then if you look at the rest of my backlog, there's no bugs. So my bugs are all in play or about to be in play. So once we go there, and again, the way we look at it, if you look what's on deck, it's going to be more bugs. And then once we drain our bugs, we go back to working on features. So that changed a lot of the dynamic. Again, we own the service, so it's our own service. We operate it, and basically it's the same dev team that operates and develop it. And again, with the mindset of, well, let's do bug first, then it puts really a good quality mindset behind it. So right now we have 15, 16 bugs, we're aware of it. The other thing that's interesting with some of these bugs, and I'll show that a bit more, for example, you look at this one. Actually, it's not a customer reporting bug. It's our telemetry. So part of going often, so when we have new features or a bunch of bug fixes, we just throw them out. We're not that afraid. So it goes out to 27 regions across the world, to hundreds of thousands of users, but we're confident that if we screw up, it's going to be a tiny screw up. And chances are we might detect it ourselves first, which is kind of interesting. And again, the key is because we don't want to have big complex bug that takes days to fix as a team, because the dev will pay for that. So the idea of saying preventing bug is a better investment, actually that's really ingrained in the idea of, you go often and you deploy continuously. So for example, if I was looking at here, so we go from, analyzing means test plan is written. So the first thing we do when we analyze, to go from on deck to analyze, means we write a test plan. So the testing is the first thing. So we do the test driven. We figure the test plan and unit test that we need to change. And then basically we can only pick them to get into implementing once it's done. After analyzing also that, again, that's kind of the idea. And then we move and we break all the tasks and we go and do the work. Once we're at testing done, the next release will pick these things. So we have a feature under testing done. Those features are evaluated by the PO, the product owner. We don't do a formal cycle. So when it's ready, at the morning meeting, we have a daily meeting. We say, okay, that will be ready to demo. Then we're all in the same team room. So the ops guys, the testers and developers, it's all the same role, and product owners and managers. It's just a team room. So okay, we're ready to demo a feature. So then we set up and basically we look at it. And if it meets our condition of acceptance, then it's go, we push to prod. Anybody on the team can push to prod. It's not a big thing. So if you look at the stories themselves, I'll pick this one. Now, there's nothing to be read there, but let me bring that bigger a little bit. But basically, those are traditional things. So, our personnel we use is Dan the developer. So in this case, we want to add additional parameter files we can throw when we add some bits on the dev box that we spin in there. We have a number of acceptance criteria, which is from a user perspective. And actually what you see that's interesting is then we have that telemetry as well. So the moment when we define what we have, we also define how will I measure success of that feature? How will I know that feature is used and that is useful and that people are picking it up? So we build it as we go, because often we create something, we think it's great because we're PO, so we know everything. But really, what we want is to say, well, where we write and whatnot. Is it documentation that's not there? Is it the discoverability? Is it the feature itself and whatnot? And then from there, if it doesn't get picked up, we can go and investigate on that. And again, as we're saying here, the first thing we do is write a test plan. We put our test plan in source control, actually, in our structure. So it's expected with everything. All right. So that's kind of the way we do the work. Let me bring that up. So once we're ready, so what's at the end? We actually go and every check-in creates a release, a potential release. So it's a candidate. So again, with that idea, we go to the different stages. So this is kind of our list of all the different things. If you look here, we have on the side, we have actually our service it's a few microservices. So it's not one big thing. So some things can go on their own independently of the other. One of the things, for example, if you look at, again, at our data warehouse, we have at different stages we go to this guy. And you see, for example, we went to prod, twice yesterday with the data warehouse. And the key here is that there's a side, again, with the DevOps mindset where we're architected in such a way that we try to limit dependencies between things. And when we do have features that required everything to light up, we use feature flags heavily. So a lot of our work is based on, we use a different feature flag. Often the data side will go first with the feature flag off. We know there's kind of two steps to this, right? There's does deploying this will break anything? And then does the feature we actually deploy work and is satisfactory? So we push early under a feature flag, and then we start opening it up. So the one that's available, our UI, is actually this guy, the RP, or resource provider. So in Azure, everything's a different resource. So we have one. So if we look RP, for example, I think this one we're there. This one we went a little further. So that was Tuesday. So I'll just open this release. So again, so those are created by the check-in. So the more traditional, the check-in starts the CI. When the CI is complete and all our tests are positive, then we create the release. And then the release puts the bits into our first dev and test environment, or dev environment. And then if everything's okay, then we go to our first ring. So here you see we're kind of started pushing it out. So it takes us, usually we do a first ring on a number of regions, and then we'll go to the other regions. And then again, we have in addition the ability to use feature flag to show to either internal only, we can pick some subscriptions, some regions and whatnot to disclose the new feature in a partial way. And I think, again, those are all good things to do so that you're not afraid to go out often. And anybody on the team, when they ran the tests, they wrote the tests, and so on and so forth, and we do have the telemetry, then it makes us comfortable to go with these techniques. So this is in RM. So if you look at an actual deployment itself, I'll just go to the environment. So for example, this is in dev, so we deploy it with a PowerShell. We do have, fundamentally this guy it's a kind of a website on Azure, and we have slots there, so we can deploy to one. Once the deployment is done, we can switch, we can swap to which one is live or not. So even in that stage, we kind of have two sub-step in there. And then we run all our integration tests. If it's good, then we go into the next one. And if it's good, again, we kind of go down. We can set some, as you saw, some approval between some of them. So often we go for a while. If everything's fine, then we just continue. So we do that on a timer. So the way we started originally was, we'd wait and we'd get some approval. Now we're kind of approved by default. So we reach a timer. If nobody stopped it, we continue. So again, from a level of comfort in there. And then again, you see the kind of the different regions we go through one after the other as we go forward. And then from there, again, in VSTS, you can see the different tests. You can get to those tests. You can see the commits you had that were related to those. So let's say that, for example, this is what came there, and then I can click there and get to my code itself and see the code change. So that integration is also makes us very comfortable. And again, because those are small changes, we go more often. So what we have is not a long list of work. If we screwed up something, we can quickly go find out what is it we screwed up. It's kind of an easy thing. The last thing I wanted to show, and I'll go quick because I'm running out of time, is a bit of our telemetry. So we're saying a lot of the bugs we actually find ourselves. So we use a combination of different tools, but the main one is App Insight. Again, that's an Azure service that we can leverage. It's available for everybody. There are equivalent other products. So this is the one we use. basically, when you set up your app on it, it collects all kinds of data for you. And then you can set different types of alerts and whatnot and see kind of what's going on with the service. For example, the average kind of requests you get on the server. We have things like, for example, if you want to go and investigate failure. And again, some of these, if we have failures, we can set, we have what we call a Batman on the team. Batman and Spiderman. So basically at the beginning we said, well, every week there's somebody who monitors that, gets the email, and makes sure that everything runs. So we wanted a way to distinguish that. So one of the PM went out and we said, well, we want something on the desk so it's obvious. So he bought like this big Batman plastic toy and a Spiderman one. So Spiderman's the PM in charge that week to answer MSDN forums and all user voice and all of these things. And then Batman is actually the dev in charge for that week. He's the first point of contact, and then he uses the rest of the team as he needs to solve it. Actually, now some of our stories are written as Spiderman or as Batman, I need this, when we work on our own engineering tool. And the question was, after it happened, like a few weeks later, I'm going, all right, so you get the guy with all the cool gadget and tricks and solve everything and whatnot, that's the dev, and then kind of the flip-floppy teenagers, that's the PO, you know? Like, how come it turned out like this? Go figure. So anyhow, that's kind of, we wanted to show a few things. We'll take questions at the end, but I think the main thing I wanted to leave that is really the idea of if you want to deliver faster, then deliver more often, smaller, I think is the main thing. And then you really need to go, again, all of the tooling is available with this one, and this is going to show another set of tooling. So it's a combination of technologies available and tools. Those have matured up over the last few years. And it's really now the idea of just try to set up the team and put those practice one after the other. So for us, again, we were fairly lucky. We started from scratch. You know, a year and a half ago, we didn't have a line of code. So it was a lot easier to start. We have I call high affinity software to do DevOps with it. In your companies, there are things that are higher affinity and those that are less. So it's often the idea of find the projects where it's easier to put all your DevOps things, and then it does work. I mean, there's enough of us now doing them, and we see enough of our own customers doing it that it's possible. But again, don't find the one or two projects in your company where it won't work. Go find the projects that it will work, start there, and then you build a muscle. That's what we've been seeing. And that's how you basically embrace DevOps overall. So I'll turn it over to Andy. And then you'll see a completely different pipeline, but with a lot of similar principles.
Hello, everyone. Can we get the slides back, Angela? Aha, there they are. Great. Let me just do this. So, yeah, thank you, Claude, for having me. It's a pleasure to be here at DevOps Enterprise Summit in beautiful San Francisco. Hope you all are enjoying San Francisco. Weed is not yet legal, even though it did win last night, so don't have too much fun tonight, remember that. So, you know, as Claude said, you know, moving fast is, in my opinion, I think everyone's opinions here, is a competitive advantage. I don't know any company that wishes to move slow. So again, Netflix feels very strongly in the value of again, moving fast because it's a competitive advantage, because if we don't move fast, our competitors will. And in fact, your competitors will do the same. And it turns out that your customers also expect you to move fast. And then if you do move fast, you get to learn. You get to learn quickly, and consequently, you get to evolve. We'll just quickly hold that thought. DevOps Enterprise. I haven't plugged it in.
He wants you to plug in.
OK, I'm going to plug it in. Over somewhere.
Take this guy out.
This is like presentation worst patterns. Oh, OK. So, yeah, if you're not moving fast, your customers will. Your customers demand, or excuse me, your competitors will, and your customers demand it. And so, continuous delivery, it facilitates moving fast, right? It's unquestionable, right? Because you take small changes, move it into environments. You can experiment. You can back out problems quickly. And so moving fast and continuous delivery is the manifestation of that moving fast. So we believe so strongly in the value of continuous delivery and moving fast that we've actually invested heavily into a platform called Spinnaker. As I mentioned earlier, I run a team called Delivery Engineering, and Spinnaker is really the manifestation of 6+ years of running at scale in the cloud. And in fact, Spinnaker is the 4th kind of iteration of continuous delivery tools. We've been running Spinnaker internally at Netflix for over 2 years. We open sourced it a year ago this month. And I'll tell a little bit more about the partnerships we have. But at the end of the day, it's open source. And we open source it for a number of reasons. One, first and foremost from a recruiting standpoint, but also we also wanted to learn from the industry and figure out kind of, hey, here's how we do things. We have very strong opinions, and they're again manifested in Spinnaker. But we wanted to understand from the rest of the community kind of what are your opinions. And the partnership we've had with Microsoft and Google and AWS has certainly yielded a lot of lessons for us. And at the end of the day, Spinnaker is an orchestration engine. It allows you to define pipelines, and those pipelines ultimately could result in a deployment to some environment. And in those pipelines, you can do any number of things like run tests, manual judgment. You can scale things up, scale them down. Wherever this goes. And one of the key lessons learned from previous systems that we'd open sourced is that we wanted the system to be pluggable. We wanted to take advantage of innovation. We saw with previous systems that people would fork it and make it work, in their environment, in their cloud. And that was great, but those forks, those innovations were lost in that fork. And so we built Spinnaker with the express purpose of pluggability so that it would be multi-cloud friendly. And also what you deliver, what software assets that are important to your pipeline is also pluggable. A bread and butter asset at Netflix is an image based, as we were talking about image-based deployments. But we also use containers. I can show that in a minute. We also deploy JavaScript applications to CDNs. And so we wanted that flexibility across the board to deploy whatever it is we wanted rapidly with a lot of confidence. And so consequently, we have a large community, a large ecosystem of people not only internal to Netflix working on Spinnaker, but external, such as Microsoft and other great companies and partners out there. Target mentioned it, I believe, yesterday. And what's great about that is the innovation in the community. Everyone gets to share in it because it is a pluggable system. And so, as I said, it is multi-cloud friendly. First and foremost, Spinnaker works on AWS because that's Netflix's bread and butter. We have hundreds of thousands of instances running in AWS across the globe. And we have very, very strong opinions about how those should be run and how they should be deployed. And in fact, that opinion, again, is very much embodied in Spinnaker with what is now kind of known as the cloud-native model, where there are applications, and then there are clusters, and then clusters have ASGs or server groups. And that's where a lot of the clouds then pick up their models, i.e., Amazon has ASGs, but there's no notion of clusters and whatnot. And that model fits really well with other clouds. And in fact, as I'm standing here today with my good friend Claude, is that we've integrated heavily with Azure. So there's a team at Microsoft we've been working with for over a year. And the key thing with respect to pluggability in the Spinnaker ecosystem is that we didn't create an abstraction. It's more of a provider model. So all the features, all the rich features you get in Azure, you can take advantage in Spinnaker, as opposed to, or in the same way you can get all the rich features in AWS. So we didn't try to abstract it out and make it so that every cloud was the same. In fact, every cloud has their own unique features, and you can take advantage of those in Spinnaker. We also partner with Google. And so there's tight integration with the Google Cloud Platform, including Kubernetes. And then recently, as my good friends at Target just announced, Target and Veritas teamed up and added OpenStack capability within Spinnaker. And so again, Spinnaker think of it as a paved road for Netflix and for other companies that leverage it, where all the best practices are codified in a single platform. And some of those best practices, as we see, again, are those strong opinions. Is first and foremost, at Netflix, everyone owns their own destiny. There are no ops teams at Netflix. When you write a service, it is your responsibility to fashion a pipeline and deploy it into the various environments that you see fit, i.e., at the end of the day, probably prod. What's more is when your application dies or has a problem in prod, it's you that gets the page at 4 a.m., not some random ops team that has to handle it. And in fact, there is a small team called Core. It's roughly, let's say, or maybe a dozen people that are on call 24/7, and if there is a problem in production, they quickly assess and they figure out what the problem is, and then they page you. And so it drives home this idea that, one, you have to build high-quality services, and you have a vested interest in ensuring they're up and running and they do a good job for our members, because you're not the one who wants to get that call at 4 a.m. that something broke. And then another strong opinion we have is this notion of immutable infrastructure. And the idea here is that we build up our software assets as a part of a pipeline, and then we share that asset across different environments and deploy it. So we don't have agent-based deployments. So as I said, the bread and butter deployment is a image. In the case of AWS, it's an AMI or AMI. So we bake that AMI in a certain environment, i.e. like a test environment, test it there, and then we copy that same AMI into different environments, i.e. prod or other accounts. And the key thing is that it fosters reliability. This thing can start up without any external dependencies, and it's really easy to roll back to previous versions and whatnot. So we believe strongly in immutable infrastructure, and you'll see that kind of embodied again in Spinnaker. And again, each team is free to own their own destiny, and every team creates their own pipelines. There is no DevOps team at Netflix. DevOps is kind of embodied in every service team. And Spinnaker acts as this kind of common, paved path that people can plug in. And what we've seen through this is that other centralized teams at Netflix and at other companies are then plugging into that paved path. So case in point, Netflix has a very sophisticated automated canary analysis team. And that product, or that, not really product, but more platform, is kind of a last line of defense, if you will. We can stand something up in production, allow a small amount of traffic to hit it. We can compare results against the previous version, and we can say go or no go. And I'll show you that in a second. And that's all then, again, facilitated through Spinnaker. And Jez Humble, who wrote a great book on continuous delivery, and he often speaks at this conference and is probably here today somewhere, he has a great quote. And he says, continuous delivery is about making deployments boring. And what that means is back in the day, Claude showed this earlier, is deployments used to be like this big thing, right? Like we scheduled them. Friday night, everyone's got to be here and we got to take care of this. And it was, just a big event that we had to plan for. And I got to tell you, Spinnaker makes deployments really boring. In fact, they're so boring at Netflix that we do it 4,000 times a day. It just happens. There's one happening right now. There's probably a couple happening right now, in fact. And so, that's the value, again, of a platform and a process and, a strong belief in some of these core things like everyone owns their own destiny and an immutable infrastructure. It doesn't matter if you're using images or Docker. It doesn't matter. You can still practice these things. And it works. It enables you to move fast and keep ahead of your competition. So I'll show you a couple things in Spinnaker if you don't mind. Would it be permissible to switch back to the computer? Yeah, there we go. Great. Thank you. Let me enlarge this a little. So at the end of the day, as I said, Spinnaker is an orchestration engine. It allows you to facilitate deployments to different environments. And that orchestration part is a pipeline. And a pipeline is made up of different stages. And those stages could be any number of things. And in this case, what I'm showing is before a deployment to 2 different regions, there's a wait for user approval. Now, not all teams do a quote-unquote wait. But again, sometimes humans are needed. Even though there are 4,000 deployments a day, some of them actually require like a human being to say, yes, I want this to go live. Maybe it's a highly critical service or whatnot. But again, every team owns their own destiny. In this case, I talk about this idea of a canary. And what you can see here, of course, my connection, let's go back. Maybe this one has a good one. OK. So this idea of we can run a small amount of traffic through a test instance and then score it. In this case, it's a pretty easy score. We all remember back in our days in school where it's out of 100. And you can have a go, no-go decision based on that. So within Spinnaker, you can say, hey, if my ACA score is less than 80, I want to cancel this pipeline. Or adversely, if it's better than 80, then we're going to go forward. In this case, after the canary happens, then they go to staging. And in this case, back to that idea of an immutable infrastructure, they're finding an AMI running in a different account. So we don't create that asset in every different account or environment. we can pull them around, and that's that idea again of that mutability. So you have this consistency across all your environments. So instead of, let's say, baking in one environment and then baking again in another one, that introduces, right, the possibility of a difference, right? So it's that same core asset, that consistency throughout the entire process. You know, and one key kind of best practice we have in Spinnaker is this idea of you can make logic decisions, right? You can do you know, preconditions. And in this case, this is a pipeline that they can throw in a certain parameter, and this is kind of almost like an emergency pipeline where they can go to any environment they need to in a quick fashion. And this idea here is that, again, a strong opinion is automate everything. There's going to be that one-off thing that you only do once in a while. It's that, you know, that once in a million error that happens in prod. And the tendency is, oh, I can just jump on that box and then, you know, fix it real quick with some command line foo. The problem is, the next time that happens and you're on vacation, no one knows how to fix it, right? So we automate everything at Netflix. And again, here's more ideas of checking parameters, and then we can run a certain pipeline based on those parameters as they come in. As I said, Netflix, the bread and butter deployments are AMIs into Amazon. However, we also use containers. They're the new hotness, and we have our own container cloud called Titus. It's much like Kubernetes. And Spinnaker integrates tightly with Titus, just like it integrates with Kubernetes and whatnot. And so in here, what we have here is an image going on, or excuse me, something that's being deployed into, actually that's not Titus, here we go. This is being deployed, this is a Docker image that's then being deployed into Titus, which is, again, just like Kubernetes. And so at the end of the day, Spinnaker facilitates continuous delivery. However you see fit in terms of every team is free to fashion their own pipelines, because at the end of the day, they're the ones responsible for what's in production. And continuous delivery facilitates a competitive advantage, moving fast. We are constantly experimenting in the Netflix UI. If hopefully tonight some of you will binge on something good like Stranger Things, if you already haven't. If you fired up Netflix with a friend of yours on 2 different devices, you may see 2 different Netflixes. And that's because we're constantly innovating, constantly trying to figure out what will make you come back and watch something else. And again, we can do that because we have the tooling and the machinery in place that gives us that confidence to move rapidly. And so with that, you wanted to...
Yeah, let's go back to the final slide, and then we'll go on Q&A. So maybe the last thing is, just wanted to talk a little bit. So actually from the Azure perspective, the work we've been working together is actually Microsoft, we started contributing to Spinnaker actually pretty much when from open sourcing. And actually, we're not alone. There's a number of companies, including Google. We actually did a hackathon with Netflix, Google, and a few other people in Redmond in our office to come up with an authentication that we felt would work for every cloud. And so there's a good collaboration there. And we also are investing from an Azure perspective on a lot of these open source tools. So Spinnaker is one, and we're looking at, for example, we also have integration with Jenkins, and we have that kind of nice way to go from Jenkins to Spinnaker, use Spinnaker to go, and actually now we announced that yesterday, deploy to Kubernetes on top of Azure. Actually in Azure we have a service called Azure Container Services, and yesterday we announced the support by ACS of Kubernetes, which is already supported by Spinnaker. So that's why I think for me I'm starting to see kind of the nice thing about open source and these communities. So we just got that instant pipeline, and we also open source actually ACS itself. So that was announced yesterday. So that's kind of how we started working together. I built a release management system, he's built a release management system, and we found that really there's a lot more in common if we go beyond the UIs and whatnot, and kind of that evolution, and again, there's kind of a learning on both sides of how to think about all these things. So I think that's maybe the last point we wanted to make on that, which this idea of immutable is something we're also kind of all investing, I think, as a community. We kept the rest of the time for any questions on Netflix, Microsoft, anything. So.
Just have a question on your
Yeah.
Just to put that in perspective, is it 4,000 throughout any type of environment? It's in production?
It's all across. So we have many different, about a dozen accounts in AWS that we are regularly deploying to. And we are a microservice architecture, so it's not just a monolith. It's hundreds of services being deployed to test environments, prod environments, and whatnot. And we've actually seen that number double since we released Spinnaker, which is showing again is people are moving faster and faster because they have that confidence.
Yes.
I know you're a big company if you're sharing your knowledge between release automation. So how can we reach out to you, like, being a mid-sized companies, like, how can you contribute, like, helping us grow in the same way, like, like big unicorns like Netflix and Microsoft are working together, Target, every big company is working together. So is there a forum, like, where we can reach out to you and pick your brains, because we don't want to reinvent the wheel, because there is a lot of stuff they have done here, so which is great.
Certainly. You want me to answer this?
Yeah.
So Spinnaker is open source, and there is for example, there's a Slack channel or a Slack team that you can join. It's totally free. And the Microsoft team hangs out in there. The Google team hangs out in there. Target, Veritas. There are actually plenty of mid-market and small companies also hanging out in there. And obviously Netflix is in there as well. And so feel free to join it, ask questions, and any number of us will help you. Because again, it is a bi-directional learning experience, and that's what's been really fun about this.
And if you go more on hello? All right. Same thing, if you pick Spinnaker, if you pick VSTS, for example, then there's all kinds of support available on MSDN forums and so on and so forth. So there's depending on kind of which community and which tool you go for, there's more and more like this openness. But the key is, it's more of a how to make it work. Like you get on the channel is we solve problems together, and it's not a come and do me a demo. It's a little more self-service on the community. But if you get involved, we're more than happy to have as many people get involved. That's because it's going to go faster.
And you can find it's spinnaker.io.
Right.
Claude.
Yes.
You're branching. The question is do you create branches per bug and per feature that you're working on, and then do pull requests, or is everybody working on main?
So we're working on main with pull requests. So we fix things and then we just put it back to main. So we don't have any long-lived branch. It's all the main pattern. I think, yeah, it works well. It's a lot easier to go that way. And again, we talked about continuous delivery. Often it's a little mistake, continuous integration and continuous delivery. So continuous integration, the way we think about it is, getting the different pieces of code together, and that you want to do every check-in, you want to do often. And then from there you get your pipeline, which is basically lending in prod to your user. That's the continuous delivery. And in most of these tools, the check-in goes, starts the process to go to production. Every check-in should be considered a candidate to go to prod. Working in parallel stuff, that just goes against everything you do from a agile Kanban perspective. It's work that's not moving anywhere. So that's not good. At least again, we're also fairly opinionated on these things. Yeah.
So interestingly enough, I know you weren't asking me, but I'm going to answer it anyways. As we support both models at Netflix, because again, every team owns their own destiny. So some teams do exactly what Claude said. Some teams actually have feature branches. And so Spinnaker has triggers. You can trigger off a Jenkins job or a Travis CI, but you can also trigger off a Git commit. And so people will have, they'll watch branches, and if there's a deployment or if there's a check-in to a particular feature branch, then we can kick off a pipeline and deploy that, that set of code in a stack that is unique to, let's say, having your name, so you can test it out. So we support both. Both are powerful in their own way.
Yeah.
You have mentioned that your team writes test plans before the coding. And how do you ensure the quality of the test plans?
They're basically, so the test plan is checked in, And there's a pull request on every test plan. So somebody else on the team needs to review it. They put their comments, and up to the point where we feel it's a good level. So it's a team ownership. Make sure every test plan is solid. So and we do it like with the same as we do code review. We do test plan review. Same mechanism.
So you don't do any automated in a way of ensuring, because it's again manual, right? Somebody writes in test plan, same people. If developer is bad, he's going to write in a bad test cases, right?
So we don't have a separation anymore between testers and dev, right?
Yeah.
So for us, I pick something. The first thing I do, if I pick analysis, it's the next thing. Then I need to go write the test plan. They write it. They do a pull request. The other people on the team will go and put comment. Often it's 2-3 people would put comment on the test plan.
Okay.
Because the key is we're conscious if the test plan's bad, we'll miss things, we'll get bugs, and we don't get to work on the good stuff. So that's kind of that virtuous cycle we're trying to maintain.
And these test plans are unit integration test cases, or?
So both. Often it will be, the test plan will be, we need to expand unit test on this, we need to add this integration test, we need to add this perf test. So basically it's really, with this change, what it is we need to add or improve or modify in our testing apparatus at the same time. And then when we do the story, the task is really the test plan itself. I didn't open up all the detailed tasks, but often the first one is write test plan. You always have all the testing tasks, and usually the last one is remove feature flag, basically. So we pretty much every story we put a feature flag, and then we can control that way as well.
Okay, so I have actually one question for Netflix. You guys are microservices. How do somebody know that somebody has an API to use and stuff like that in Netflix?
It requires a whole lot of communication and coordination between teams.
Okay.
So and that's at the end of the day. The architecture is fairly well known amongst the teams, and so if I'm going to make a change, I need to collaborate with you. I'll let you know, hey, we're making this change, or if you need a change in me, you'll come to me and say, hey, I need this new API. And so it's handled that way.
Okay.
How do your products support teams that are in highly regulated environments so that they have to sell these tools to compliance and auditors that are asking them, about these things that are touching production?
I know on the VSTS side, that's probably one of the strong suit. I don't know if you saw, but I didn't go through all the tabs, but everything that happens to that release, all the way to the code change, all the tests that run, so you get a lot of information there. And then again, you can set some of those stages. You can do the same thing in Spinnaker, which are manual review for certain role. And so you can automate that, and even the manual step that somebody needs to sign up. Of course, if you can get these guys to sign up, to replace their signing up by having some framework that is used and invoked, even better. But at least on the VSTS, you get everything that happens to it, from the code check-in to the release to all environments. So it gives you have all that traceability that you're looking for. So that's one of the first reasons when I started in release management. That often was kind of the one thing, specifically after old people, Sarbanes-Oxley. Yeah. So that's the way on the VSTS side. I'll let you.
Yeah, and on the Spinnaker side, so Netflix is a publicly traded company. We take your credit card, so we are both subject to SOX and PCI compliance. Those teams leverage Spinnaker. So we do have segregated AWS accounts where we can kind of control that. But at the end of the day, all the auditing is plugged into Spinnaker so that who does what is captured, and then we can also, from an authorization and authentication standpoint, say that you can't touch these apps in this PCI compliant environment, but Claude could. So we're able to meet all those compliance requirements.
And the counter side is to make sure also, Bob doesn't have the rights to go on this prod server and change things. These things work with the idea that you use a tool to change anything in prod, and at the same time, then your ops or IT guys cannot go directly to prod. All your change comes through the pipeline. So that's also the other discipline aspect of that. And again, you can close it out through security and accounts and whatnot. That's a good question. Yep.
Can you give example of dependencies and what do you do to limit the dependencies
So the question is, how do you do to limit dependencies to go faster? How do you handle them? So for us, part of it, I think I mentioned it, again, taking a microservice architecture, I think helps with that, so that you can try to have every one of the services as independent as you have. But when you get into dependencies, there's the idea of one of our definition of done on many changes is that you're able to support previous version so that they can be pushed. So you can push something that says that's a breaking change. If I resort it back, I'm going to break the rest of the world. So if every one of our components is resilient to the previous version as a basic and something you test against, then that limits a lot of these dependencies. And then the other thing for us is feature flag. Like the idea that you can control multiple services together with one feature flag and saying, all right, like me as a PO, I can actually go and say, okay, now we feel comfortable, we're making it available to the world, and then I flip a switch and we're good to go. And that will affect all these different services looking at the same flag.
Yeah, I would say yes and.
And?
Additionally, for like binary dependencies, or dependencies on let's say other systems to get things that like boot up and whatnot, is we try to do that up front in baking. So we incur a cost because it takes longer to build that image, but then we can move fast once that image is built because it has no outside dependencies once it fires up, let's say. And then there are dependencies in a microservice architecture. Service A depends on service B. And so pipelines can be chained. So a pipeline can call another pipeline and vice versa. So you could then have that dependency in that, anytime I deploy foo, I need bar as well. And you can codify that in two different pipelines or the same pipeline. And again, it's all automated.
Yes?
Yeah, so this is a pretty big topic, but you mentioned feature toggles and feature flagging. Can you just give us kind of an overview of maybe the way you manage that mechanism, that sort of thing?
Okay, well, okay, so for us, basically it starts in the code. So in the code, we have kind of a feature factory, if you wish, a standard model that we use to define the behavior in the code. So we go look to a value. So when the user comes in, basically we go, okay, so based on who's coming and based on what they're using in characteristic regions or internal, external, and whatnot, we go, all right, so, Andy, you're coming in on my list of current active flags. We get yes, no, 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 yes, 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 no, no, no. So every one of them is decided pretty much when you come in. And then based on that, we have the same code and we isolate those decisions into a common methods that we use at the top. So there's an initial cost, and internally we have a CDN where basically when somebody comes in, we need to go get, based on his characteristic, what he's going to see. And then from there, the code is not changed as much. Right now, we control those things. Actually, we have them in all our flags are in a file in source control. So we just change it, and then basically that we deploy the file as a deployment, and every time we deploy, we basically have the difference in the feature flag. We're thinking of doing something more automated and maybe add some UI on top of it, but it works well. Like the principle is that we found that the team has been starting to use them more and more and more for pretty much everything. That's our pattern, maybe.
Yeah, and you're right, it is a huge subject. There are multiple systems at Netflix. Obviously, Netflix experiments constantly, so there's a whole A/B testing platform where we bucket, you all into different buckets, so we can show you different experiences. How that's manifested again in the code is we have a sophisticated system called fast properties, and these are just runtime properties that we can feed a system or a service. That's obviously looking for it, and that's how the feature flags can be toggled. And the beauty is, and it's not a sales pitch, but it's all done through Spinnaker because it's a pipeline, right?
Right.
Because these runtime configurations, you can affect scope. You can say, I want to change whatever is true to false. That's a terrible one. Is live to true, global. Or I can say I want to change it just for this application, or just for this instance, or just for this ASG, or just in this region. You have all these different scopes. And so we've learned through the course of many, many disasters that when you go like global, things like unexpected things happen, right? This is live true. All of a sudden, House of Cards is live, 2 weeks early, hint, hint. So So what we do as Spinnaker is we automate that. So you can say, hey, I want this thing to go global, but I don't want to start global. I want to start small, and then I want to slowly ratchet it bigger and bigger so I can test the blast radius. And again, you can do that through a pipeline. So change, is live to true just to this, let's say, instance in this region. Then, I have another stage I can run some tests and verify everything's kosher, and then I can go a little bigger. Maybe I'll do the whole region, and then eventually I'll do the whole globe. And that avoids, again, these like just gigantic fires where everyone's panicking. And so again, that's facilitated through a continuous delivery platform.
Yeah. And the key there, the other, I think we both touched on it indirectly, but it's really also your telemetry. Like having a good telemetry tool for your A/B, and so you create the flag, but then you need to take those flags as we have a unique value that we use in App Insights then to go compare like different behaviors and whatnot. So it's okay to have a flag. There's a few reasons for feature flag. One is to de-risk my deployment, but another one is really the learning. Like we just ran an experiment last week where we improved click-through on a certain thing by 4%. So we kept that. Another one, we reduced it. So that was not so good. So we killed it. So different customers see different behaviors, but you want to know about it. You want to know what they do afterwards with those different behaviors, which one work, which one doesn't work. So that's kind of the other side. So you need to set them up in code. You need to define them. You need to be able to switch them to your pipeline, and you need to be able to get the telemetry and analyze it. We have 49 seconds left.
So you talk about telemetry. Does Spinnaker take that information into account to scale up once the pipeline's already connected?
Yeah, exactly.
Can you repeat the question?
So does Spinnaker take into account telemetry for scaling? And the answer is yes, certainly. In the case of AWS, we're plugged into, let's say, CloudWatch events, and we can auto-scale based on telemetry coming in from how many people are using it and whatnot. Yeah. And you can affect those rules within Spinnaker. It's the same with Azure and GCP and whatnot.
Yeah.
Do we believe it's a good idea to use Spinnaker for a standalone and monolithic application?
Do I think it's a good idea to use Spinnaker for monoliths? Sure. I mean, at the end of the day, if it facilitates, deployments for you and you can do it rapidly and with confidence, there are certainly companies out there deploying monoliths with Spinnaker, and if it provides value, sure, I would recommend it.
Can you tell everybody that our drawing will be a 1 at our booth?
Okay. All right, so I've just been told for those who registered for the drawing of the drone at the booth, at the Microsoft booth, drawing is at 1 o'clock.
Yes.
All right, okay. Woohoo! Woohoo! If you haven't registered yet, you get 45 minutes.
Where are they doing the drawing at?
Where are they doing
At the Microsoft booth in the expo. So,
Thank you, everyone, for
all right.
showing up.
Thanks.